Welcome back to our lesson, girls. So today we're going to be looking at an introduction to the parabola that you've been examining through your assignment on Desmos. Right, so let's have a look at parabola in more in detail now. In a parabola, there are two types of parabolas, okay? The first parabola is if you have a shape going like that. It's also called minimum or concave up. And if you have the parabola going upside down, it's called a maximum or concave down, okay? Now, within a parabola, there are a couple of features that you gotta know. And the first thing is called a turning point, and it's also called the vertex, and that's the coordinate of the peak of the parabola, okay? And axis of symmetry is the line that cuts a parabola in half, okay? And it always has the equation x equals to some number, okay? Before we get into all those details, let's have a look at why a parabola looks like that. We're gonna look at why a parabola looks like that by filling in the table, okay? And let's use that equation, and then let's find out the values of the y values when you have these x values, okay? So when x is equal to minus 3, if I put it in here, now you need to keep in mind when you have a negative number, you have to put it in a bracket like this, and then put the square on top, okay? If you don't put the bracket, you'll get the wrong answer, okay? So that's going to be positive 9, because if you don't put in the bracket, you're going to get negative 9, and that's wrong. So always put anything that's got a negative number in a bracket, and then square it, and that's 4. Similarly, minus 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So what we're going to do is we're going to plot these on a number plane and see what it looks like. So starting with minus 3, let's go all the way up until 9, so that's here. From minus 2, let's go up to 4, that's here. So once you plot these out, let's link them up. And you'll find it looks exactly like what we've been sketching. So that's why the parabola looks like that, simply because if you put the numbers in the table of values, it comes out like that. So let's now analyze a parabola. So question 2, it says write the missing features for this graph. Question A, the parabola has a, once again, because this is an upside down, because this is an upside down parabola or concave down, it's called a maximum, okay? Question B, the coordinates of the turning point. The turning point is where the peak is, in this case, minus 2 and 4. Question C, the y-intercept. The y-intercept is where does this graph pass through the y-axis? Right there. So that's the y-intercept, 2, okay? The x-intercept, where does it pass through on the x-axis? Here and here. So that's 1 and minus 5. Okay? And the axis of symmetry, remember, is the line that cuts the parabola in half. So in this case, it's that. And it goes through minus 2. So it's called x is equal to minus 2. You have to write the x, okay? So what you'll notice, the axis of symmetry is always the coordinate of the vertex as well. It always cuts in half through the vertex. Let's do something similar in question 3. Question 3, determine these key features of the following graphs. So let's have a look at question C in specific. It says find the turning point. So turning point, once again, is find the coordinate of the peak. If you look at the grid and the number, that's obviously 2 and 5. So that's your coordinate of the turning point, 2 and 5. Question II, axis of symmetry. So once again, that's the line that cuts the graph in half. So that's x is equal to 2. X-intercepts, does this graph or parabola, does it touch the x-axis at all? Obviously not, it's above the x-axis, so there is no x-intercepts, okay? Question IV, where does this graph pass through the y-axis? You can see it's there, just above 6, so that'll be 7, okay? So that's how you would read or analyze this parabola. Question 4 now. Copy and complete the table below for the following graphs. So for question 4D, we're looking at y equals to minus 4x squared. Let's have a look. Is this curve a maximum or a minimum? It's upside down, so it's a maximum, okay? Is it reflected in the x-axis? So compared with that, is that reflected in the x-axis? Yes, it is. It's flipped over. So yes, it is reflected. What's the turning point? The turning point is the peak of the curve, which is just the origin, okay? Because remember, that's 0. All right. What's the y value when x equals to 1? So if you look at the graph, So from 1 on the graph, if you go down, hit the graph and go across, what value is that? That's the question. And that answer, from what I can see, is -4. So that's your answer, -4. Okay, so that's the y value. Y equals to -4. Is it wider? Is this graph, blue graph, wider or narrower on the one above? Well, that's pretty obvious, that's narrow. Okay, so as we learned from the assignment, the higher the number in front of x squared, the narrower it becomes. Alright, last question, girls. Question 5. Copy and complete the table below for this. Let's have a look at question C in specific. What's the turning point of that? Turning point, remember, is once again the peak. So the coordinate of that is 2 and 0. So it's very repetitive. It's the same thing as what we've been doing. Axis of symmetry, that's the line that cuts in half. That's x equals to 2. Y-intercept, what's the y-intercept? Well, that's the point where it cuts through the y-axis, and that's 4. The x-intercept, as you can see, it's 2 because that's the point it passes through the x-axis. So the x-intercept is 2. Okay? So yeah, girls, pretty easy stuff. That's all you basically need to do. You just need to read a couple of information from the given graphs. Okay, girls, try all of the exercise from question 1 to 6. And yeah, let me know how you go. Thanks.